Hey guys, welcome back to Mr. Samuel's channel. Today we're going to be learning rational functions and vertical asymptotes.
Here we go. I don't know if you heard that. The microphone's kind of okay. There I am in my white shirt. Hey, look at this though. Greatest band ever. Anyone know what this is from? Just take a guess. Star Wars. The Biff band. Okay. All right. Now listen. Oh, this is wrong. I gotta go here. Okay, perfect. Okay, you don't have this, but what I want is tomorrow the plan is ultimately just all the how to graph these things. You've been shoved pictures in your face. You don't even know where this is coming from. This doesn't even have an equation with it. But even with the equations, the picture's been supplied. Tomorrow we're going to put it all together, and then you got to create the picture. So just make sure you understand it. Get your graphing calculator out. I'm going to show you a feature. I got to open up mine too. Okay, now I don't know if you heard this or not. I made a management decision last night and then on the way in today that this was a whole nother day of notes, which is over. It's overdone. I just want to introduce you to vertical asymptotes one more time, and then limits that we're going to see on vertical asymptotes, not end behavior. What's happening around a vertical asymptote. So if you want to write this down, fine. I forgot to, in the notes as we continue, to reference this again. We'll reference it tomorrow for sure. Yes, what's the matter? No, I don't. Sorry. Okay, and I got to get this movie going, so just watch. It's not important, but I watch this new feature. Okay, so here we go. First things first. There's my pen. Good start. Is draw this vertical asymptote. Again, I don't have an equation for this one. And no, I just saw someone flipping their paper. No, you don't have this. Okay, so you can put this somewhere or just watch. She actually introduced the video as well. So anyway, aren't you glad you're sitting here? All right, at your seat. Okay. So first of all, our asymptotes are x equals, which is x equals -5. And then it's x equals, what am I doing? X equals 2. So vertical asymptotes are x equals x equals. Get ready to have your highlighters out as well. So go ahead and grab those. I needed 5 highlighters. I only have 4 though. So if you have 5 highlighters, this is going to be awesome. Okay, but we're only going to use 1 on this one. Okay, now watch. And I got to hurry up because first hour I missed the last example. If the bell rings and I'm not done with the last example, I'm going to keep videoing it and then just watch like 2 minutes of the video at the end if you really want to understand. 2 minutes of your time. I'm too busy. Whatever. All right. Anyway, so here we go. Input, say it. And I want me to be able to be seen on the screen here, so I'll move this way. This is what's happening. Okay, and this is what we're looking at. Well, first of all, before I do that, -6 comma. Well, that's -6 comma. Looks like right around -1.5. Let's just say -2, right? Right? That's what input output means. When you see a picture, this is -6 comma -2. Input -6, output -2. Pay attention over there. Snap, snap. Okay, now as I go closer to -5, let's say like -5.5, comma, what happened to that y value? Did it get larger or smaller? Careful. Smaller. A bigger negative, right? But actually smaller. And then let's pretend that I went even closer to -5, like -5.1. What happened to that y value? It got bigger or smaller? Smaller. So what's happening as I get closer and closer to -5 on the left side? Where are my y's going? Don't make me throw out my back. -infinity. But then what happens when I go to the right side of -5? -4 comma, let's just say 2. Okay, -4.5 comma. Did that get bigger or smaller? That's easier. Bigger. And then what about -4.9 comma? Boom. So where is this going when I jump to the right of this asymptote? Positive infinity. So here's your first highlighter. That's what this notation means right there. If you wrote this down, sorry. If you didn't, fine. And I might forget to do this. I got to move that because it looks like a plus sign there. That's what that means. That minus at the end of that -5 for this limit means I'm jumping to the left of -5 here. Nathaniel and Nathaniel. This is not for your class. This is for Compass. Okay? Okay, all right. So that's what this means. And then I actually I just did this. So maybe we'll highlight that in yellow. That's where the graph is going, just to the left of -5. It's going to negative. You got to go. You got to leave. Didn't you read the pass? All right, go. All right, and then on the right, he's still not moving. Do we have to pick him up out of the desk? Okay, I got it. I didn't know if I needed a help or what. Not really sure what's happening here. Okay? Teaching in America. Okay? Teaching in America. That means to the right. I hate those passes. I have ADD and it's an interruption and I just get all thrown out of whack. Is everyone okay? Okay. Now, there's no clap. Okay, now, here's where we're going to go to our calculator. I'm going to teach you for the first time in forever how to type this in your calculator. Now we got to cover a couple things. Number one, with your graphing calculator out, how many people have this kind of calculator? Like it's the fancier colored ones, and then look at this button right here. I just found this out. I found out two new things yesterday. I didn't even realize those new upgraded calculators, that's where your fraction button is. Boom. You see that? Because I'm going to type this on my graphing calculator for the first time in forever. Okay? All right, but everyone else, if you don't have that mode of a calculator, you just have a regular TI-84, regular TI-84, you have to hit alpha y equals, and that's where the fraction button is. How many people do not have that option either? Does anyone not have that option? So everyone can do the fraction button. Good. I'll just leave it at that. Second hour, we should be able to do it. Of course, I forgot this is a video. If you don't have that option, then you have to do this. You have to do numerator in parentheses, no right answer. Close, and then divide denominator in parentheses. No parentheses, no right answer. Okay? And then hit zoom standard, not waiting for you. And then you should see this picture. Well, I'm going to go back. We're in second hour, so I'm going to do the fraction button. I'm going to do the fancy fraction button. Alpha, I just learned this yesterday because not all calculators have this. So this is a newer feature, and I never even looked at that symbol there. Crazy that I found that out yesterday. And then, sorry, where's that? Oh, it's right there. It's throwing me off. X squared. This is what everyone in this class should do then. They should use the fraction button, and therefore they don't have to use parentheses. That's what's nice. The numerator and denominator separated. Boom, and I got the same picture that I saw before. Okay, now this is what I'm going to show you. I'm going to show you a new trick that I learned yesterday as well. Pay attention. Hit, not window, second window, which is table set. And I already have mine set on this. One of our teachers yesterday in a meeting that I did not want to be in, because we weren't supposed to have meetings, actually did show me something useful. Turn that into ask for the independent. Then I'll show you what this. Dom, are you doing anything? Look like you're about to fall asleep too. Okay. Well, your eyes closed for a second. I was worried. It's just a really long blink, I guess. Everyone good? Okay, now go second table. Clear. Oh boy. I wonder how I clear all this. Darn it. That's what I did in the other hour. How do I get rid of this? Oh no. Oh no. No, I don't want that there. You guys have nothing there, right? Don't you have nothing? Oh my gosh, you're killing me, Smalls. Second table. And then mine doesn't look like that. Did you turn it to ask? I'm blown away right now because I actually deleted that function too. Didn't I delete it and then rewrite it? I can't believe this table is there. I don't know how to clear this out. This is blowing my mind. Well, this is what I was going to do. You see this table right here? They're doing this numerically, trying to assess what happens here. Then it turned all those numbers into fractions. This calculator's killing me. I'm blown away. But that's what I want you to type. I want you to type these numbers in that screen. So I'm going to try to do that. Let me change it. Let me put like 1.999 first and press enter. Good. And then 1.99. I'm going in reverse order. Well, that one didn't change. Let me put 1.9 there. I don't know how to delete that. What? Why is it giving me a fraction? 1 point. Is it delete?
Yeah.
Wait, delete.
You gotta put like this.
Delete. There we go. Delete. There we go. There. You're gone. Okay. So delete. So this is what I wanted. 1.9, which is just to the left of this. And that, by the way, I didn't tell you that, but that's what we need to know. Vertical asymptotes come from zeros in the denominator. So I definitely have a vertical asymptote at x equals 2 for this graph. Okay, but anyway, let's go back to that table set. I don't know why it's giving me fractions. I think there's a setting in it did not give me fractions last hour. Love technology. Anyway, all right, and then note. Oh, good face there. I like that. Okay. Notice when I put 1.9 or 1.999, I'm just to the left of 2. What kind of number is that? Really, really, really what? Small. Okay, and then let's go on the other side. 2.1, 2.1, 2.01, 2.001. We have to understand that that's getting closer and closer just to the right of 2. And 2.001 is right next to 2. It's like right there. But I can input it and get an output. What kind of output is that? Really, really, really what? Large. So we saw those. I didn't even do that last one, 2.0001. So the limit of f of x as x approaches 2 minus, highlighter, minus means from the left. That answer was those values, which was getting very, very large negative, which means if I kept going with that thought process, I'd theoretically get to negative infinity for those outputs. Okay, and then the limit as we'll change colors, f of x as x approaches 2 from the right. Hit that in blue and hit that in blue. But you may have not written this down because you don't have this on your paper if you still didn't realize that. Those numbers became really large. Okay, so tomorrow we're going to incorporate this. I may forget it in the rest of our notes today. I just wanted to cover it. In last year, this was supposed to be one whole day on that concept. Not necessary. What happened here? Oh, okay, yeah, right. Sorry, I just confused myself because I'm old and decrepit. All right. Okay, now go back up to this. And again, I know what some of you may be asking. How do I know that this is what the graph is going to be for this thing? How is this happening? That's tomorrow, okay? This is certainly a unique one. And then that, by the end of our notes, or the second to last example, it should all come together, all right? But I may not have to be able to do that vertical asymptote thing again because there's some more stuff. All right, so here's the first thing. Why do I not see a vertical asymptote? Why does this graph look the way it does? There doesn't seem to be an interruption. It's because vertical asymptotes come from zeros of the denominator. So let's put that up here because I don't have space. Vertical asy. That comes from taking 2x squared plus 4 and setting it equal to 0 because the denominator cannot equal 0. Right? Remember, vertical asymptotes are tied to domain issues. Do that real quick if you did put that over there. The fumble! My precious phone, oh my gosh. All right, my life. Vertical asymptotes. And then what happens when I solve for x? I get 2x squared equals negative 4. What kind of number am I going to get for this when I keep going? Imaginary. There's an I number here in this solving, so that means no vert asymptote. And then that's why our graph doesn't see any interruptions. So guess what the domain is? All real numbers. By the way, I got to do something, otherwise I'm going to lose my mind. Okay, remember when the paper shifts on me and I just get so happy when that happens? You got to remember that this has to be done. Okay, now, and I guess there's no highlighting for that. All right, zeros. Now, something funny over there. Zeros are, write this down, x-intercepts. Is a FATRAMACT. We're also going to put a section for y-intercept, and then this is where we're going to get our fancy little highlighter out for this. Here's where you get zeros. Let's go ahead and highlight this here. Zeros come from this. I'm going to write it once and expect you to understand this. But x-intercepts, write this below. Everyone should know this in this class. X-intercepts are 0 for y. That's what you're supposed to do. So y-intercepts are, oh man, look at my ugly face on that screen. 0 for x. Oh, my nose is huge. Holy cow. I think I need nose surgery. All right. Time for plastic surgery for Mr. S. Look like one of those plastic people in their 70s. All right. Anyway, so here's the zeros, the x-intercept. 0 equals, I'm going to write this down. This is the only, I'm only writing it once. 0 equals 2x squared minus 8 all over. Nope, that's not that song. 2x squared plus 4. And then what are you going to do to solve for this? Anyone craw? Anyone craw? Cross multiply. What happens to the denominator? What happens to the denominator? It's gone. So this will always happen. You will always have, I got to move this line. You will always have the numerator equal to 0 for finding the zeros. Okay, so I'm going to highlight this again, blue, and then blue. And then my question is, what multiplies the -8 and adds to be 2? You know what first hour did? I'm not answering any of your questions. Nothing. They didn't say a word. So what multiplies the -8 and adds to 2? Did you hear him? Did you hear him first hour? You're bums. Bums. Nothing. Of course, someone gave me an evil eye today. I don't know. Teaching in America. Arr, arr. Kids actually growl. All right. Now solve, and you end up getting -4, 0 and 2, 0. Hey, look at the picture. -4, 0 and 2, 0. I'll be. And then the y-intercept. Honest to God. Oh, no. My highlighter. What's yellow and blue make? Green. We better just go green then. Here's the y-intercept. It's right there. Why? Because when I plug in 0 for x, these just turn into 0 plus 0 minus 8 over 0 plus 4, right? Everyone should be able to do that. As a FATRAMACT, this is what I do. I go like this, get my hand, and say, okay, y-intercept, I just cover these up. Okay, it's -8 over 4. That's what the y-intercept is. So I'm going to put this above here, 0, -8 over 4, and then reduce. That's 0, -2. And then I'll highlight that in green. So there you go. We can highlight this and knock around the parts that we're going to have to, get taken care of here. I'll be darned. And maybe I could just use that highlighter. There it is. Look at that. Maybe highlight that point right there. Maybe that's what I should be doing. And then highlight those zeros. So, hey, there they are. I just found them, and I know that they exist. They're right there. Okay? Good idea. All right. Thank you. You're welcome. He's having a conversation with himself now. All right. And then the limit of f. Oh, I'm sorry. My bad, dogs. What about the horizontal asymptote? What is the horizontal asymptote? Well, you know what? I really screwed this up. This blue is really messing up everything. So I guess I'll do this peach color. What is the horizontal asymptote? Notice what I looked at there. What is the horizontal asymptote? y equals 1/2. And if you don't know that, you're severely and totally behind at this point. The rules for horizontal asymptotes are when the degrees are equal, it's the coefficients in front of those equal degrees. All right? We did a whole thing on that yesterday as well, another rehash. There you go. Look at that. Dun, 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 dun. Right through 1/2. That's what the graph is being controlled by. That y equals 1/2. Okay, so the limit of f of x as x approaches infinity. We won't do a vertical asymptote. We don't have a vertical asymptote, so forget it. Forget that comment. 1/2, and then the limit of f of x. That's an I in there. Just give me a break. As x approaches infinity, still 1/2. So, and then you know what? Highlight that in whatever highlighter you picked for the horizontal asymptote. We need to understand that the horizontal asymptotes dictate the end behaviors. That's a connection. I did that with our quizzes on Tuesday. Had some questions and we made that tie-in for sure. So everything builds. And we come into somewhere and say, I don't know how to do anything. We got to do better. We got to get our notes out and look at it. And then that note inspires your brain back into class. It's a time warp. All right. Oh, yeah. I remember when he said this. Now I can put it on my homework. Okay. Well, we do have a new thing here. But then the last example is actually pretty good. And really is probably the example that works for tomorrow as well. We got a problem, though, on this one. This is quite unique. Good Foiler, say it. So one of your first steps in tomorrow is going to be factor each numerator and denominator. Get it factored if you can. What multiplies a -12 and adds -1 first hour? -4 and 3. I have rights. I don't have to answer your questions. Does anyone notice what happens? Does anyone notice something? You can cancel. You know what this does? This removes a vertical asymptote. That is not a vertical asymptote, nor is it a zero. This is what's called a hole. Can anyone say hole? That's what this removable discontinuity it is. It's a hole in the graph, an interruption. It's still an interruption in the domain, but let me do that last. And let me just focus on that. Let me just focus on these three things. Okay? You know, and I want the y-intercept is 0, what's -12 over -4? 3. Okay, so I can do that. The y-intercept is 0, 3. But we're going to find it is. It's actually this new graph. This is what we're going to graph now. G of x equals x plus 3. That's really what this picture looks like, except this is still a bad value for the domain. The reason is when I plug in 4, if you care, I asked you this question, I believe, on Monday. What is 0 divided by 0? And the answer was still undefined. We did a joke. Is it 1? Is it 0? Or is it undefined? And it's still undefined. So here we go. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1, stop. That's what's happening with this. There's an interruption. You got to graph that as a hole in the graph. You math 3ers, you seniors, you should remember this from last year. I remember on the board, Mrs. Shavanik, when she was in here 2 years ago with the math 3ers, I saw all these rational functions on the board. All right. And then one more thing. What is the 0? Let's highlight this first highlighter. Boom. The zeros are the zeros of the numerator, which is -3, 0, which makes sense. Because then when I connect this should be a line. This is a very unique rational function. So this is what happens. We got to incorporate when there's factors that are equal and cancel. All right, and make sure that happens. I'm going to do you one further, though. The hole we are going to have to write as a coordinate. So it's 4, and then you know what? How to find where the hole is located? You plug it in the new function. What's 4 plus 3? Input, output. What's 4 plus 3? And then look at this. It is 4, 7. There's 7 for a y value. Good. Okay? So it is at 4, 7. So the hole, the interruption in the graph, is located at 4, 7. All right. So now I can go back and do domain. We went through that whole thing to still tell you that the domain is still interrupted at 4. Still. Even though it's kind of sneaky. Because if you cancel and ignore that you canceled, you may miss that. All right. So that's another new concept. All right. So we're kind of building the graphs. I built this graph. We actually did our first graphing of a rational function in this class by ourselves. Okay, and then I added some stuff here and added some highlighting. Okay, so one of the two new things. One is, what are zeros? They're x-intercepts. And what they are is the zeros of the numerator. Keep in mind, the zeros in the denominator create vertical asymptotes from Monday and Tuesday, and I think even yesterday we talked about vertical asymptotes. This is what I mean about, we gotta lock in. Gotta lock in. Right, so added a couple things to that, that long sentences there. I like the highlighting and just get to the basics without all of those words. Okay, now I really like this one. This one is like what we're going to be doing tomorrow, man. This is like the beginning of, and by the way, tomorrow is the last new stuff. And the test or quiz is not till a week from today. So then Monday, Tuesday, Wednesday, just clean up. Everyone do their share. So what's the first step we're going to do? We're going to factor the numerator, factor the denominator. I don't have time for this. If you still don't know how to factor, that's on you at this point. There are just things that just have to be taken care of. And then what multiplies the negative 10 and adds to 3? Anyone? 5 and negative 2. Are there any holes? Are there any removable discontinuities? Good. Happily do this because on the quiz, I know we got 1 or 2 that happen. They're rare, but we're going to make sure you know them. So that's good. This is a normal, everyday, typical situation. I'll do the domain last. By the way, we could see this picture, x plus 5. That's that vertical asymptote, x equals negative 5. Get ready for a highlighter. We'll pick something here. X equals negative 5, and then x equals 2. X equals 2. I'm going to grab a highlighter. Let's pick blue. And blue. That's where those came from. The zeros of the denominators, if they're not canceled, like the last one, are the vertical asymptotes. Okay, fine. I can do the domain now. And we're going to color this in blue. So negative infinity to negative 5. Union that negative 5 to 2. Union that 2 to infinity. This is the long, obnoxious interval notation way of saying all real numbers except negative 5 and 2. I do like to say because it's a lengthy writing statement, so it gets a little old. Okay, here we go. Now we highlight this. That's the zeros. Nice, good choice. What's green? What's green and yellow? Isn't that just green? What's blue and yellow? Green. So I have a good choice for y-intercept. Y-intercept. Oh, no, I'm good over here. You want it in this form, so I'm good over there. That's your y-intercept. So I'm going to sneak that in here, then write them both. Y-intercept. The y-intercept is, write it like this so you really see it. Y equal, or 0 comma, 8 over negative 10. Then I'll tell you about the AP exam. We heard, I didn't see the actual grading, but we heard that they don't really care about unreduced answers. Not really the main idea. I'm not taking points off for not reducing a fraction at this point, which I don't like. I think they should. Get them. All right. And then, hey, let's highlight that. And then let's highlight that. There they are. There they are on the graph. Okay, use your highlighter instead of making them as a dot. So you got your connections and colors. All right, and then we'll see. This is how we construct tomorrow. Oh, and by the way, sorry, we should have already done that. Did you just hear someone yawning like Chewbacca over there? Glad I can help. I told you at the end of the year, I have products that I can sell. One of them is an alarm clock, but it's also puts you to sleep. There's two modes. One, if you need to go to sleep and you're insomniac, you press the button teaching. Then you just start teaching a lesson, and then the alarm is, wake up, what are you doing in my class sleeping? Right? It's great. Anyway. Okay, anyway, let's highlight that in blue. You charlatan. I got all my words in there. You know, I put a crinkle, crinkle. All right, there we go. All right, anyway, that's done. We filled in all those parts. Now let's hit this sucker. All right, and this is where we ended on the other. Right, 9 o'clock. It ends at 9:08. As you leave, I'll probably do this last one in the video as you're walking out the door. We'll be able to get this one finished. All right. So above here, and we'll do we need 5 highlighters on this one. This is great. That's why I said 5 highlight. I don't have 5. Okay. First of all, if you don't know how to factor, that's how I feel about you. Okay. We've been talking about it too long in this class as well, and you're supposed to be trained. It's supposed to be review. Okay, so it's x minus 3, x plus 3, and then what multiplies a negative 3 and adds to negative 2? Boom and boom. Do I have a whole? Yes or no? Yes. These cancel. So I'm going to put that right here. That now what I have to do is think about h of x equals the new function, but I still have that interruption, so I can't screw up. And then, you know what I'm going to do? How do you find the coordinate of the removable discontinuity? We know it's at 3 comma, because 3 is that naughty value for the x minus 3. And by the way, this is no longer a vertical asymptote, and this is no longer an x-intercept value. This turned into an interruption in the graph. So those are out. That's why those won't be color-coded. What I do is I do h of 3 of the new function. I plug in 3 into the new function after the whole is removed, or after the factors cancel. What's 3 plus 3, everyone? 6. What's 3 plus 1, everyone? And I guess I can't mark you wrong for leaving that, but it just gives me the shakes. You know, it really does. Okay, so here's highlighter number 1. Yoink, yoink. You choose your colors. And then maybe this. How did I get that y value? You know, how did I get that y value? I plugged it into the new function after canceling. That's what I don't know if the other teachers are doing that yet. They should be, I think. We're going to do domain last. All right, and then next, we're going to highlight this. What's that for? Which one of these things here? Zeros. So that's zeros. That's simple. That's just going to be negative 3 comma 0. That's an x-intercept. We'll highlight that in yellow. Which one's this? Which one's that green one? Which one is that's left here? Asymptotes vertically. All right, now we're going to write that in here. There's going to be a vertical asymptote at x equals negative 1. This is exactly where we're going to go tomorrow. Tomorrow it's just going to be right into, this is what we do step by step. All right, before we even think about a picture. We're not even going to graph this picture yet. Tomorrow we'll take care of that. All right, and then, my last highlighter, so I'm going to have to double use. What's this for? Well, look at what's next. That's for what? Horizontal asymptotes. Oh, I hate when that goes off. Oh, no. Did someone unplug the... What's going on? Your purifiers off. You jerks. Is it going to blow up? Is it going on? Let's get nuts. Sorry, we had an incident I had to take care of. All right, so that's y equals, what's the answer? What's the answer? Y equals what? Wrong. 1. Here, let's write it like this. It's 1 over 1. 1, 1. 1 over 1. And we'll leave it as 1 over 1 for teaching, learning purposes. Well, review, because that's Monday, Tuesday, Wednesday, we've been talking about horizontal asymptotes. Now, I hope you have a fifth color. I don't. I'm going to go back to yellow and hit this. What's this for? What's the only thing left? Y-intercept. So the y-intercept is 0, comma, 0, comma. This highlighting idea is just really, it came to me today. Never taught like this before with the highlighting. 0, comma, 3. Right? So I just wanted you to see that it's -9 over -3, that part of the graph. Because again, your eyes, you're just going to go like this. Okay, that's the y-intercept. 0 minus 9 over 0 minus 3. All right, and then what's the domain? It's still all of these issues. It's -infinity to -1. Sorry, union -1 to 3. Still the whole issue, and then 3 to infinity. And I can't highlight that. It's just, I guess I could double highlight it. It came from the removable and the vertical. So part of the blue and part of the green. If you wanted to do that, be real fancy. I think in the other hour, this is what I did. I went like this. The domain is these two issues. Okay, so you could also do that. All right, good. Go ahead and put your stuff away because we are at 08. I am going to go ahead and do this as you leave, though. And I want to go really fast. Okay, removable discontinuity. I can see this point here. Now this is a picture. So this is 1, 2, 3, 4, 5, 6, 7. So it's at 7, comma 1. The zeros, it looks like I'm at 2, 0 and -2, 0. 2, 0 and then -2, 0. Vertical asymptotes. It looks like we got an interruption right here. So that looks like 1, 2, 3, 4. That means x equals -4. No highlighters. I got no time. Horizontal asymptote? Wait a minute. That doesn't look like a horizontal asymptote. That looks like a, anyone? Slant asymptote. But I'm not going to bother finding the equation. It looks like it crosses through -2 and then rise 1. I'll make a guess. Y equals 1x because it looks like a slope of that, and -2 as a y-intercept. That's kind of like a nice little guesstimate. Looks like it goes through -2 approximately with a slope of 1 approximately. Probably not quite. I think that slope's a little bit less, maybe like 1/2, but you're not going to have to do this. So you'll have to find it for real if you had an equation. And then a y-intercept for sure estimate, that's awfully small. It's not 0, 0 though. This dips down below. So it'd be 0, comma, not even a half. It's probably like 1/8. I don't know. And don't freak out where I got that number from. It's just smaller than a half. It's like barely there. Okay, so then what is my domain issues? The asymptotes, -4. That's supposed to be U. And the whole, which is at 7. So seeing a picture, we can do that. But here's really where we need me here. What are these intervals, and then what are they doing here? All right. This is leading into solving an inequality, these next things. Notice this first interval from -infinity to -4. That's from here to here. Where are my output values? They are negative. What's happening at -4? That's a vertical asymptote. The graph is undefined there. Put a 0 with a slash through it. That means undefined. Or you can put undies. UND, undefined. And then from -4 to -2, see ya. -4 to -2 is that little sliver there. This is where the graph is. So that is where the graph is positive. That's all we're doing. And then at -2, that's where we get a 0. Great. And then from -2 to 2, that's this little interval, super small there. The graph turned negative there. Negative. All right. And then at 2, that is a 0. And then from 2 to 7, we are positive. 7, we're undies. And then 7 to infinity, we're positive again. Okay, so that's what we're talking about here. I'll highlight those in input say it, those outputs are positive over those intervals. So that's not really a big deal. And then what we could do, I don't think you have these on your notes. We could answer this question now. Hey, where is f of x greater than 0? Well, that's positive parts. So it's from -4 to 2. I can highlight that in blue. And then union that with, this is annoying because from 2 to 7, 7 is an undefined value. And then union that with 7 to infinity, and then I'll grab my highlighter. That coincides with these and these portions, because that's where the outputs are positive. So it's the same analysis. And then where is f of x negative? I guess I was supposed to highlight this. Yoink. Oh, but also equal to 0. Yoink, yoink. So that is from, this is weird, negative infinity to -4 equal to 0. Wrong! That's an asymptote. So it's undefined here. So negative infinity. What are you doing? Oh my gosh. -4. But because this is, I need another color. Blue, green, yellow, peach. I guess I have to do, let's circle it. Let's circle it in that fancy color there. That's why this is that. Because -4, it's undefined there, so I can't include, cannot include that as an answer. Union that with -2. I like putting brackets just around -2, and then union that with 2, not an interval, one number right on there. Okay, I'm done. Said I was going to be short on that. Still passing period, so good to go.